This is section 6.4, solving absolute value equations and inequalities, begins on page 353. And our objective or goal today is to solve absolute value equations and inequalities. Example number 1 on your note-taking guide says solve the absolute value of x plus 3 equals 11. It says because x plus 3 equals 11, the expression x plus 3 can be equal to both 11 or negative 11. Again, both the positive and the negative terms that we're going to look at. So when x plus 3 equals a positive number, this is how we're going to have it. X plus 3, or the absolute value, so of x plus 3 equals 11. Notice on this next step, you lose the absolute value symbols and you make it positive 11. And we'll look at the converse of that in just a second. So you have x plus 3 equals 11. Get rid of plus 3 like we always do by subtracting 3. And if you do it on the left side, subtract it on the right. And that's how you get x equals 8. When x plus 3 is negative, notice on this next step, you go from the absolute value of x plus 3. It leaves the absolute value symbol, and positive 11 in this case becomes negative 11. You still do the same steps. You get rid of plus 3 by subtracting it. Except when you subtract 3 on this side, this time now you're going to have negative 14 instead of positive 8. So x equals negative 14 or x equals positive 8. You have your two possible answers here. And you can see the answer has two solutions, 8 and negative 14. And or work almost synonymously when you're talking about equations. They're going to work a little bit different when we look at inequalities, because every now and then you'll come up with one of these answers and it won't work. Like you'll have possibly you have 8 or negative 14, and when you plug them back into the original equation, they might make a problem, or they might make something that doesn't come out to be a true statement. Like this one right here says 8 plus 3, or the absolute value of 8 plus 3 equals 11. When you plug it in, equals 11. And when you do the absolute value of 8 plus 3, you get the absolute value of 11. That does, in fact, equal 11. So that's a true statement. And we plug in the same thing. We'll plug in negative 14 in its place. It's the absolute value of negative 14 plus 3 equals 11. Absolute value of negative 14 plus 3 is going to be negative 11 equals 11. And that one's a true statement also. So both of them are true statements. But every now and then, like I said, when you plug them in, you'll be able to eliminate one of your answers. In this case, both 8 and negative 14 are correct. See down here, it says to check it and substitute both of your values in. That's what we did right here. Example number 2 says solve 3x minus 7 plus 5 equals 9. The only thing we're going to do right here is before you eliminate your absolute value symbol, we're going to isolate the absolute value on one side. What we mean by that is, as you're looking, here's your equal sign right here. Remember, that's your balance point. As you're looking at the left side, you have the absolute value of 3x minus 7 plus 5 equals 9. Before you go ahead and make it either positive or negative, you want to undo plus 5. You want just that absolute value to be like it is in that second step. So you want to get rid of plus 5 by subtracting it. When you subtract 5 there, you do the same on the right, and you get positive 4. Now you have the absolute value of 3x minus 7 equals 4. Then on the next step, you lose the absolute value symbol, and you get 3x minus 7 is positive 4. Undo minus 7 by adding it. Do the same thing to the other side. 4 plus 7 is 11. Now you have 3x equals 11. Divide by 3, and you don't even need it. They left you a blank here. Remember, you don't need to take it to that step right there. 11 over 3. When you divide by 3, you get x equals 11 over 3. So that's one of your possible answers. The other one is when it's going to be a negative number. Still, notice this first step is the same on both of them. Before you actually make anything positive or anything negative, that first step is the same. You want to get the absolute value by itself. So get rid of plus 5 on both sides by subtracting it. When you do that, 9 minus 5, you get 4. You get the absolute value of 3x minus 7 is equal to 4. Then on the next step, like we did here, we'll change it. We'll leave the absolute value and just make it 3x minus 7, but this time it's going to be equal, instead of a positive 4, it'll be equal to a negative 4. Get rid of minus 7 by adding it. Add 7 to this side. Negative 4 plus 7 is going to be a positive 3. Then you have 3x equals 3. Divide by 3, just like we did on the other side, and you get x is 1. So your two answers are 11 over 3, and again, you don't need to do this. 11 over 3, and x equals 1. If you made it 2 and 2/3, 3 and 2/3, it's okay. Just wasn't necessary. So x equals 1 and x equals 11 over 3. Then it says check those solutions in the original equation. So just plug them back in real quick into the original equation, see how they work. Check the 1 is a whole lot easier. 3 times 1 minus 7 plus 5 equals 9. A lot of times when you're checking this kind of stuff, you just need to mentally do it. You don't need to actually write it out. So 3 times 1 is 3 minus 7 plus 5 equals 9. 3 minus 7 is negative 4. The absolute value of such equals 9. That's 4 plus 5, which is a true statement, 9. You can do the same thing with um, 11 over 3. Remember, you can always cancel out fractions by getting rid of the divide by 3 by multiplying everything by 3. When you solve an absolute value equations and inequalities, it says each absolute value equation or inequality is rewritten as two equations or two inequalities joined by and or. Again, and is what you're primarily going to be dealing with, or, like I said, when we look back at the equations for example 1 and 2, and or kind of works synonymously. You can use both of them, but when you're talking about inequalities, it's going to act a little bit different. Like the first one says, the absolute value of ax plus b is less than. You have is less than and you have is less than or equal to. Both of those are going to be an and inequality. They'll be and anytime you see less than or equal to. The rest of them are going to be or inequalities. The absolute value of ax plus b is equal to c. Notice that's an or inequality. Same thing with greater than is an or, and greater than or equal to. That one's also an or. Also an or. But when you look at them, again, the equation, the one that says equaled, is easy. You don't really change anything except making one of them positive and one of them negative. When you're looking at your greater than or less than, when you're looking at your inequality symbols, notice how they flip. When it says the absolute value of ax plus b is less than c, you write it as ax plus b is less than c, just like it is, and ax plus b, notice less than flips and becomes greater than, and positive c becomes negative c. So you flip both the symbol and the sign of what comes after the inequality symbol. And you do the same thing when you're talking about the greater than statements, these down here. Ax plus b, or the absolute value of ax plus b is greater than c. You write it as ax plus b is greater than positive c, or ax plus b, and it flips around. It becomes less than, and c becomes negative c. This one says solve the absolute value of 5x minus 7 is less than or equal to 23. So you have 5x, you set it up two ways. 5x minus 7 as the absolute value is less than or equal to 23. So you'd set that up as positive 5x minus 7, written just like it is less than or equal to 23. You write it just like it is without the symbol. The other way you do it, you write it as 5x minus 7, except this time we reverse our symbol. It becomes greater than or equal to, and positive 23 becomes negative 23. This is a less than or equal to inequality, so we're going to make it an and inequality. So it'll be and. We work through that. We work through just like we've been doing, get rid of minus 7 by adding 7. So you have 5x, 23 plus 7 is 30. All we did was add, so you leave it as less than or equal to. Divide by 5 on both sides, and you get x is less than or equal to 6. And do it the other way. Add 7. Do the same thing here. 5x is greater than or equal to negative 16. Divide by 5 on both sides, and you get x is greater than or equal to negative 16 over 5. Again, you don't need to make it into a mixed number form. So your solution is going to be all real numbers. That's just talking about everything we're dealing with. Greater than or equal to negative 16 over 5. And, again, because it was a less than inequality from the beginning, it is an and inequality. Numbers that are less than or equal to 6. So when you graph something that looks like that, since it's an and inequality, remember you're going to have an overlapping area in the middle. So it'll be numbers that are less than or equal to 6 and greater than or equal to negative 16 over 5. So they're both or equal to. You'd have colored in bubbles for both of them and the area in between the two. And when you write your inequality, since it is an and inequality, you put them together. Negative 16 over 5 first, positive 6 second, x in the middle, and then write your inequalities just like they are. This one says x is less than or equal to 6, so make it say x is less than or equal to 6. This one says x is greater than or equal to negative 16 over 5, so just write it, since it's x is first and negative 16 over 5 second, flip them around. When you flip them around, make sure you flip the inequality to match. Example 4, solve the absolute value of x minus 11 plus 2 is greater than 8. Just like on the equations, you want to get the absolute value isolated on one side of the inequality. So what the first thing you're going to want to do is you're going to want to subtract 2 on both sides before you try to do anything else. That'll leave you with the absolute value of x minus 11. So the value of x minus 11 is greater than 6. From there, one's going to be positive and one's going to be negative. Absolute value of x minus 11, you lose the symbol and you leave it as positive 6. On this one, you lose the symbol. You flip the inequality around from greater than to less than, and you make it negative 6. Then when you add 11 to both sides, you get x is greater than 17, or x, when you add 11 here, is less than 5. And since that started off as a greater than inequality, we can see it at the beginning. It started as a greater than inequality. It is going to be an or inequality. And remember, those are a whole lot easier to write and graph for most people. You write it as x is less than 5 or x is greater than 17, written just like that. Open circle, since it doesn't say or equal to. First checkpoint says solve the equation. The first one, x minus 3 equals 7 or x minus 3 um, x minus 3 equals negative 7. So x minus 3 equals 7. All you're doing is you're getting rid of, you're making one positive and one negative. Add 3 to both sides. So x equals 10, or and in this case, add 3 to both sides again. X equals negative 4. So you come up with two separate answers. For the second one right there, you do 4x plus 10, or x plus 10, equals 34, and 4x plus 10 equals negative 34. So you're just losing the inequality symbol, making one of the answers positive, one negative. Subtract 10 on both sides, and you get 4x equals 24. Divide by 4 on both sides, and x equals 6. Subtract 10 on both sides, you get 4x equals negative 44. Divide by 4 on both sides, and x equals negative 11. So you have x is 6 and x is negative 11. For these inequalities, it says the absolute value of 3x is greater than or equal to 18. So 3x is greater than or equal to 18, or 3x is less than or equal to, remember you flip the inequality symbol, and positive 18 becomes negative 18. Divide by 3 on both sides, and x is greater than or equal to 6. Divide by 3 on both sides, x is less than or equal to negative 6. X is greater than or equal to 6, or x is less than or equal to negative 6. Same thing with this one, except you have x minus 7 is less than 16. And since it started, this was a greater than, this is a less than, this one's now and x minus 17 is greater than negative 16. Remember, you want to flip the inequality and flip the sign. Add 7 on both sides. X is less than 23. and add 17 on both sides, x is greater than 1. Then add 7 on both sides, not 17. X is greater than -9. So written as an and inequality with the x in the middle.